share my screen. So can you see my screen?
Yes, Karthik.
So can you see? Yeah, yes. So what did we discuss in the yesterday's or previous sessions class? We've seen what blocks are, and we've seen what dynamic blocks are, and we have also seen how to import certain blocks which are already existing in our AutoCAD. So how do you access those blocks? You have to go for Add Center, enter. So as soon as you go to Add Center, you'll be greeted with this catalog. So here, whatever the discipline you are from, you can actually download those blocks, and you just go to Design Center in the Add Center. So whatever the discipline you are from, you can use the default blocks that are present. If you're from a HVAC background, you know what I'm speaking of. You can just go to blocks. You can see the injectors, condensers, or there may be uh, like any pipelines connections, such type of things which will be present by default. There you can just quickly drag and drop for the component, that particular component. And also, we have also discussed what the dynamic blocks are. So what are dynamic blocks? Dynamic blocks are nothing but just a block which has certain functionality. In a way, you can actually change its dimensions and sizes in the block itself. So let's just quickly check a dimension block. Let's say we are going for architectural metric, and we are selecting a particular block. Let's say we have window. Let me just quickly drag and drop this window over here and see what those dynamic blocks are. Let me close this window. As soon as I can click the block, I'll go for PR, that is properties. PR indicates whatever the property you are selecting. Let me just draw a line. And if I select on that line, you'll see the properties of that given line. So what is the layer of the line? What is the line type, line weight? And if you scroll down, you can see the length of the line. Same way, we have selected a dynamic block. And add someone. Hi, sir. Good evening. So dynamic blocks indicates like when you select a dynamic block, it has certain properties. These properties can be viewed in the properties tab. Over here, you can see its door width and wall. As you increase or decrease its width and wall, you can see there is an increase in property. Like if I want to increase the width, I can just simply drag like this. So here it's increased. The wall's width we have increased from 150 to, if you increase or decrease, it will be displayed over here. You can see it's already increased. So in order to like fit, let me just give an example over here. I just draw a wall, and let me offset this. Say 150. So we have 150 mm wall. So here you can see the wall is of 450 mm. So this block, normally, if it is not dynamic block, it is useless for us in this case. This is a window, and if you want to create a window, to fit this place, what you have to do is you have to again create a line, something like this, and draw a line in between. You have to do manually this process. So if you are using a dynamic block, what you can do is you can just directly have your width here, like this, change. Now all you have to do is you have to just move and place it. I've just quickly switch off F8 so that I can place wherever I want. So this is my wall, and I have placed the window on my wall with just modification in the properties bar itself. So again, one more thing is for this width, this width of the wall, the door width is something, say 1200. You can just customize here with the given heights 1200. You can see the window has automatically changed its size without me creating one more block for the given window. So that is called dynamic block. And you can explore, there are multiple options for dynamic block. You can create the block for various purposes, for column sizes, for wall thicknesses. So there are multiple properties and advantages of dynamic block. once you try to explore them, you can get the gist of it. So these are our blocks and dynamic blocks. By this, we have known all the properties for creating a, a model or a plan in 2 dimensions. Let me just open my presentation. So if we can view this object over here or this image over here, you can see this drawing, right? Whatever that is drawn in this drawing, we have tried to draw already in our drawing. You can see the walls, the windows, the doors, the furniture, hatching, everything that is there here, we have tried to draw successfully in our 2D environment. So is that the end of the drawing or anything else is there? So the main purpose of any drawing, as we know, is end of the day, it's going to be either in construction or in manufacturing. It is going to be in the hands of the one who does the work. If it is in construction, say the site engineers will give to the persons who build. They have to ultimately understand. So some cases, what happens is, if you are giving only 2D blocks to them, they may not get an idea of what this thing is going to be once it's completed. Or let's say you have completed the whole project in 2D and you want to present it to the end user, that is the client. The client may not understand each and every nuances or details of this project. He wants to see how the building looks externally, like how it's going to, once it's completed, how it's going to look. So for them, you cannot actually give the 2D drawings. You have to give something in the form of 3D, which they can visualize. Okay, this is how the thing is going to look. This is how once it's completed, like if it is a machining part, in order to know exactly how the block is going to fit in the other components of the assembly, if it is if you can generate a 3D view for that object, it will be like very much understandable for all the team members. Like if you are designing one component for an object, like an entire assembly, and if you could project that object in a 3D shape or a 3D view, others who are assembling some other project may get a better understanding of what we are doing and how the whole assembly is going to happen and what individual fittings are, sorry, going to take place. So if you can view this drawing that is there, this is one of the oldest drawing that is drawn by a painter called Leonardo da Vinci. He was trying to explain some form of archery or some form of equipment he designed. You can see here, if you can observe here, this is a circle. This is a circle, and he has compressed the circle to a form of an ellipse in order to represent in this drawing. I just try to try to observe this drawing. He can not project this drawing in a pure circular way. If he can project this drawing in a circular way, others will be disturbed. So what he tried to do in that age, like it may be a like 400 years old drawing, you can see he took this circular thing and drawn in the form of ellipse. He compressed this direction so that it can fit, and he can give the whole element like this. If you present like this, he knows that he'll get a better 3D view of whole picture. Like that, you can see they have drawn. We have tried to draw the whole object in a 3D view to generate the whole picture. So this is what the ultimate aim of any drawing should be like in order to understand, or like if you are presenting the drawing in a paper which and giving it's a perspective, you have to give the whole drawing in a way that it is understandable, at the same time it is presentable. So I just want you to observe this drawing, this image. This is what a human eye sees, right? Here, this line is a straight line. This track is also a straight line. But according to our human eye, when we see this both lines, parallel lines together, you can see at some point it like we will visualize it at at some point they are going to merge. But in reality, is it the case? No. These two lines will never merge. But to our human eye, to our vision, what we are going to see is they are going to merge at some point. This is what called perspective. From our perspective, if we are going to see, like standing from here, these tracks are going to merge at some point. Okay, that's what our perspective is. This is what we have to represent. If you are drawing something in 3D, let's just remember this particular point. Now, if we draw as per the perspective of a human, like if a person is weaving from this direction, how does he weave any object in any given direction? Those type of drawings is called as perspective drawings. So there are multiple types of drawings are there, but let's see in construction or in machine design or in whatever type of design we are using, even it is in artistic form or it is in like a precision form, there are only two types of drawing. One of the type of drawing is perspective drawing. So what is perspective drawing is, you can see it is a technique to create a linear illusion of depth. Here, what is linear? Linear is in a form of a line. It will be in a form of a line. So in this type of drawing, you are trying to create not X, Y, and also Z. So you can see we have X axis, we have Y axis, but you are giving a Z axis also. That Z axis will be given in the form of a linear way. So at some point, if you're drawing in a linear way, it has to end. You have to remember that. And also, as the object gets further away from our viewpoint, it will be disappeared. Okay. Here they have given decrease at a constant rate, but remember it will be disappeared. So again, in perspective drawing also, we have two types of perspective drawing. One is 1 point, the other one is 2 point. Let's see what they are. So the first image, you can see all the lines, straight lines in this given drawing emerge and try to fit in this one particular point. They, as you extend your viewpoint, they will decrease or converge into one single point. That is called 1 point perspective. And the second thing is you have three blocks over here, and if you are looking from two directions, they will merge in a single point. That is called 2 point perspective, which has two vanishing points. Like say, if you are looking from this angle from here, and your view is extended to this direction and this direction, at some point your view has to end. Like if you go to this picture, this is a 1 point perspective. What happens is all this views, all this like race, if you imagine in a kind of race, is trying to end or emerge in this given area. So when you see in this particular image, you can see these lines are like emerging in this area, and as the distance progresses, it is trying to vanish. That is how we try to construct the 3D environment in a paper, in a 2D perspective. So here, one more example that explains how a 3D image can be drawn. Like this is a view. We have trees and we have buildings. So as you draw something like this, the center point over here, it is trying to converge the whole image, and whatever the angle we try to maintain, the perspectives will be with respect to this given image. That is what 1 point perspective is. So let's try to see what 2 point perspective is. Here, the observer is trying to view from this direction. So as his view extends in this direction, it is going to converge at some point. And in this direction also, it is going to converge. Here, this is highlighted because we are near to this object. As our view progresses, whatever the view maximum length we can see or we can draw, it has to give an angle. You can see it is trying to decrease with respect to this particular shape. That because here we are standing and we are looking in both directions. At some point, they have to submerge. from this direct in this direction and in this direction. That is called as 2-point perspective. But the thing is, if you're drawing perspective drawing, they are not scalable or they are not as per our two-dimension drawings. These perspective drawings are only used for artistic renderings only. They cannot be used for manufacturing or let's say they cannot be used for constructing by taking these dimensions as proper dimensions. Let's say you are having a perspective image over here. This measurement, whatever the measurement over here, will not be your actual measurement. This measurement also will not be your actual measurement. So you have to be wary of that. And always remember, perspective drawings are for artistic renderings and also for visual appeal only. So is there any form of 3D drawing possible? Yes, there is one more type of 3D drawing possible, that is called isometric projection. So here's a small example. We have something like this in our front view. And when we see that in top view, that looks like this. By taking these two views, if you try to construct a 3D view, that will appear in the form of this. So here you can see these two views will not give a proper justification or explanation how an object is going to look. Okay, we have front view, we have top view, but with these two views, if we are not able to construct something like how it is going to look in a reality, that is why, or that is how we need isometric projections. With these two views, we can actually generate isometric view, which looks like this. So when someone sees this type of projection or this exact image, they can understand, okay, this is an object. From front, it is going to look like this. Top, it is going to look like this. So which means we are going to have a cut of material in this whole cube here and here. So we'll take a cube first and we'll remove material over here and here. That will result the object for us. So if a machiner or manufacturer, if he is going to have three set of drawings, both orthographic views and also isometric views, it is easy for them to manufacture or when they are inside to construct. So this is called isometric projection. Let's see what what are the different like ways or types. So isometric drawings are also called isometric projections. Is a method of graphic representation of three-dimensional objects used by engineers, illustrators, and architects. As you know, architects will use this isometric projections. Here, the advantage you can see here, if I take this dimension, even in 3D, that will be the actual dimension of its 2D. Whereas in the case of our 2-point projections, whatever the dimension that is there, it will never match the actual dimension. It may be matching at some point, but not all the dimensions. But here, if you talk about isometric drawings, wherever you see like this length over here will be the actual length of that particular wall. And also the window sizes, whatever you're taking in isometric drawings, the dimensions will be true dimensions. So here, one more representation image you can see. This is side view, this is front view, and this is top view. So if we are having front view and right view in the left direction and the top view in the bottom direction, so you can imagine what is the perspective of the drawing. Can we tell the projection of the drawing? We have discussed, right? Yeah. Yeah, tell me.
The perspective of the image will be.
Sorry?
Perspective of the image will be, I think it's 2.
No, I'll just try to come back certain slides. Here, you can see the front view is front, the right side view is in left, and top view is bottom. So what view it will be? It will be first angle projection. So which is what we use in India. We've discussed right in the second or third class. So that's what we are seeing here. You have front view, top view in the bottom, and also right side view in the left side. So when you see look in this direction, what you see, you can see this and you can see this, right? That is what represented over here in the side view. Right side view is present in the left side view. And when you see from top, you can see this line, and this line, right? And there is a cut. That cut is represented by this line. You have three views. But even if you have three views, if you are confused, you want to give an actual representation of that object, we are going for.
Excuse me, sir.
Yeah, yeah.
Sir, the image given is that on the bottom. We are looking on that image, image now.
Yeah, yes.
Sir, from top view, I think it's clear for me. But on the side
Okay.
view,
Yeah.
Side view and front view is it?
Yeah.
Is
You
it
can see if you're looking from this direction, what is the image you see? L, right? From here, if you're trying to look front, what is you are going to see? You are going to see this, right? Right, Jason?
Yes, sir. Yes, sir. I
So
just
this
looked
is what front.
through the opposite side. I just looked through the opposite side. That's why.
No,
It's
no, no.
okay,
So
sir.
if you're looking, this is the right side of this particular object. If you see from right side, what you're going to see, this box, that is what we've represented, and this small box. And the separation between these two is this line. This line is on top of this particular box. This is the box, this is the line. So try to visualize this when you are looking dead straight. Every 3D object will be turned, can be turned to 2D if you are looking dead straight of that object. Even in reality also, just try to observe the things around you so that you'll get to know what these views are exactly. So here, the isometric views has no vanishing point. You can see whatever the perspective you are taking, there is no vanishing point, which means so the dimensions which we are giving will be true to all the sides. And also, isometric views are very accurate, but not artistic. So, here, the artists have rendered such beautiful views. This is a handmade sketch. So this type of beautiful views is not possible by for isometric because whatever the dimension is there, it is presented. And humans are not programmed to view in this way. As you've seen in this image, why I have put this image is if you draw an isometric drawing of this, it will not look good because humans are not programmed to view in that way. Like how we see this image is what we enjoy or is what we are programmed to see. So if you draw everything in 3D like this in isometric drawing, it will not look good, obviously, because we are not programmed or we cannot see in this format. Human eye will always see in the perspective we only. So that's the thing to remember. That is why we will not use isometric drawings when you are trying to draw artistic views. Artists, if you're drawing handmade sketches or if they're drawing people or paintings, they will never use this isometric drawings. But when it comes to production, when it comes to engineering, the scale, if you see these drawings, they will definitely be in isometric because we don't need any artistic views on this. We need precision in this so that they can be sent to final ring of people who will definitely going to use this drawing. By seeing this, they have to know what is happening. And also, if for example you don't get these three dimensions and you are going to get only this dimension, seeing this dimension also they have to represent or can manufacture the final product. So that is the use of isometric drawings. Let us quickly try to draw isometric drawings. Okay, the first class we have discussed about function keys. Everyone remembers, right? So what are function keys? Function keys. So where does the function? Where will be the function keys? You have used, right?
Top of the keyboard at the
Yeah,
top of the
they
keyboard.
will be in the top of the keyboard. And function keys are present so that we don't have to manually present or manually click everything. So they are just like a keyboard shortcuts, which enable us to have certain functionalities which saves us some sort of time. So we have seen what F7 does. F7 will switch on or off our grid. We have seen what F8 does. F8 L, if I draw L like this, if I try to draw a straight line, I'll turn on F8, which makes me draw the line in X or Y axis. The same way, there is one more function key, which is F5. Before going to that, we have seen what planes are in our presentation. I'll just quickly go to this. So we have seen what planes are. So this one, and if you're drawing some third axis, it will have a plane in our direction. So there'll be three planes, X, Y, and Z in any drawing. So planes are nothing just you can imagine planes as a piece of paper. So we have default two planes. In order to activate third plane without going to 3D, you can actually access this with the help of isometric option, which is present over here. You can see if you want to turn on or off your isometric drawings, you can go here. But is that the only option? Can you not draw your isometric drawing in the drafting mode itself? Yes, you can draw. How you can do that is L enter or PL enter. If you want to draw polyline, just PL enter. And you have to give your first point. Just remember, whenever you try to draw an isometric drawing, it will be of 30 degrees or 60 degrees only. Here you can see, sorry. Here you can see, we are trying to give some amount of angle to this object so that it will appear in a form of 3D. That angle will be almost all the time will be most of the times 30 degrees. So if I draw a straight line like this over here, and if I measure that angle, that will be 30 degrees. So what happens if you try to invert this or anything to 30 degrees, you're trying to create a form of depth to it. So this object, if it is not given angle, it will be present in a straighter form. But if you try to give some amount of angle, that will look, that will have a sort of depth. So we are giving a perception of depth for that given line. So in order to draw that, I'll just quickly draw a line like this, something, and you can see the angle is 30 degrees, right? The same angle here, what happens is, so we have a cursor like this, and we are having a straight line reference. Now, if you want to measure or give, I'll just try to explain over here. You can see. Okay. Now, I have drawn L. Let's say I'll take center point over here. Okay. Yeah, I'll switch off F8. Now, if I want to draw a 1000 mm line, okay, how do I get 30 degrees? Okay, I am placing somewhere like this. How do I get 30 degrees exactly? Just try to draw 1000 mm and try to draw at the rate, give less than 30. Your command like this.
So instead of giving like that,
Yeah.
excuse me, sir.
Yeah.
It is easy to give for the next box the angle on the
No. I'm just trying to give a shortcut. The shortcut is just try to L enter or PL enter. Okay. You have to give a first point. After that, what you have to do is you have to press at the rate. Okay. After pressing at the rate, you have to give your distance. Giving the distance, next is you have to give your angle. If it is less than 30 degrees, you can give 30 degrees angle. So this angle will be 30 degrees to this line. Let's see if it is true or not. Dimension. Let's go to insert. or align dimension, this point, this point. I'm not measuring dimension, I'm measuring angle. It's 30. So you can give manually also, but this will be like saving a lot of time. So as soon as I go to any point, you can drag that line forward. You can see there is an angle, a dotted line, right? You can do that way also, but it's more of a convenient way if you give at grade. So after that, if you go like this direction, you can see from that point, you have to give one more angle. So that is why I've selected this coordinate axis. So you can see if this is 0, this will be 90, this will be 180, and this will be what?
270.
270 and 360. So remember, we are trying to give an angle only in this direction, x and y direction. And 180 degrees will be our total length. Just don't go down. So if I draw on a line like this, okay, now if I want to go or come like this, I have to give whatever. You can see there is 137, right? Which means this from this direction we have given less than, which have given 30 degrees. So after 90, whatever the angle that is there from 90 to 180, we have to give that angle. Got my point? Or shall I explain again? So first we have drawn line. Okay. In order to give a line, one more line like this in this direction, the angle should be between 90 and 180, because this is what our angle should be. If I draw one more line, which is of 30 degrees, I'll just try to extend here. But if I want a line like this in this direction, I have to give an angle between 90 and 180. So what angle should I give? That according to my design. But normally I have given 30. So 180 minus 30, what is an angle?
150.
Sorry?
150.
150. So let me try to give 150. Here, 150. I have given 180, 30 degrees angle, and I have drawn something in 150. Now what I can do is I can just simply copy, paste like this. This one also, copy, paste like this. Now I have my sort of a square. In order to give depth, I'll just copy. You can see if I am dragging parallelly to this object, I have a dotted line difference, which indicates I'm trying to drag this parallelly. Then again, I'll try to draw. I'll enter. Just try to drag and connect these 2 points. I'll enter. Try to drag these 2 points. Again, I'll enter. Just try to connect all the 4 corners. I'll enter. 4 corners. Now, if just try to take this over. If you are looking this as a cube, okay, what happens is you will see this side, this complete side. I'll just uh, control or select everything, J enter. I'll just join. This side also, I'll just try to join. This is the side. This is what you see from this side. So if you're looking from this side, you can see all the 4 corners of this cube or cuboid, and also 4 sides of this cube. What else you're going to see? 4 sides of this cube, this corner. I'll just join. So if you're looking from this direction, you will see this side completely, this side completely, this side completely. So whatever the things you are not going to see, if you are from a mechanical background, or if you're drawing a mechanical drawing, you will not erase them. You'll just simply change this to dotted. can see if you're from a mechanical discipline, if you want to represent something which is not visible in the given view, we will do that in the form of dotted line. But if you are from other discipline, you can just simply select these lines, select this. Now, this is what our cuboid looks. Even if you try to hatch this also, and just go to gradient hatch, you can see an object. There is like I have to. You like there is a distinction so that you'll. So like this. So here, this is a representational image of something which is drawn in a form of 3D. It will take time if you draw as a default thing. So what AutoCAD has given us is AutoCAD has given a separate environment for us to draw isometric drawings. That is in isometric view. In order to achieve or in order to go to isometric view, you have to simply go to this here. If you turn on this with a click, you can see automatically the grids have been changed. Earlier it used to be straight. So there are three types of views that is available in isometric drawings. One is isoplane left, the other one is isoplane right, the other one is isoplane top. So if you are selecting this isoplane top, whatever you are viewing will be from the top. So if you select isoplane left, whatever we are viewing will be from left. If you select isoplane right, whatever we are viewing will be from right. So these three views are enough for us to generate any 3D object. Let's say the top, you can give top angle, the left, the right. If we are having three configurations, we can draw any 3D object. Let us see how we can draw any 3D object with these three options only. Let me go to isoplane top. So this is our top view. Now I just go for PL, enter. Now let me just turn on the ortho mode on. Now just give the dimension of say 2000 mm, and so you can see this is not going to travel in any direction because we have switched on the ortho mode. Let's say we are having trying to have a cube in this direction only. I'll give 1000 mm in this direction also. Enter. Now you can see 1000 mm in this direction also. So if I want to continue like this in this direction, we can give 1000 mm in this direction. And lastly, you can close. So this is not 1000 mm, I guess. Or you can just simply PR and enter. So we have a small cube like this. And this is a joint one. So in order to copy this view, I can copy this view with CP enter in any of this particular view, right? Just try to understand. This is a piece of paper. And if I want to copy in this particular plane, I can copy like this. But if I want to change the plane, I can simply go to this here. Let's say I'm trying to copy in one more direction. Let's say isoplane left or isoplane right. Now we can copy in another direction. But I'll just go to isoplane top also again. Select this. If you want to try to do something in midway, then you can just press F5. So it will automatically change the plane for us midway. So again, I'll just enter CP. So if it is trying to copy in one direction only, just try to hit F5. Now you can see I can go in another direction also. This is one more plane, right? This is left plane view. If I go to right plane also, I can copy. Now you can understand the difference. I am trying to copy this particular drawing in another plane. You can see as soon as I hit F5, my plane is changing. So here I can change or sorry, give the distance. After giving the distance, I'll just press escape. And now I'll just go to PL, enter again. Quickly try to connect all the dots, all the edges like this, and one more edge is there. You can see from this to this. Now we can see how much ease we have drawn the object. Now after that, you have drawn something in isometric environment. If you want to switch back to a normal environment, just press this. Your isometric view will be off. You can be again in the normal view. You can just move this drawing anywhere. So isometric view enables us to draw any isometric plan with ease. You have to just have a hold of it, how to draw, and with baby steps, you can increase your pace. So with normal line commands or polynomial commands in the actual drafting environment also, you can draw with giving just angle. Now we have tried to give at 30-degree angles, right? Let me just take a line like this. We have given 30 degrees angles to the straight line, and we have drawn straight line, and we can again here we have drawn 150 angle in order to create here. In this environment we can draw, but in isometric environment we don't have to give anything. I just try to measure the angular dimension between these two. You can see it's 30 degrees, which means we have drawn an isometric projection here in isometric environment with much ease compared to our actual environment. Now let's try to finish this. There are certain things that we did not do in this. So I'll go to isometric environment by clicking here again. Now this is a cube, and if you are looking from this perspective, this line or this line should not be there in this given angle. So I'll just go for TR, press enter and see if deleted that. If you are looking from this angle, the bottom, this is like why should we remove this line? Because it is in the bottom of the cube. So if you are placing a cube in the surface, you cannot see this bottom, right? That is why we have to remove this bottom part. One more thing we have to remove is we have to remove this part. So when we view something in these directions, only these planes will be visible. The bottom part, like the part that is present in this corner, is not visible in this particular isometric view. Is it making sense? Have you understood what I'm trying to explain?
Yes, Karthik.
Yeah. So that is what isometric views are. And let me just draw one more something like this. And let me give a dimension of 3000 mm. So if I draw up or down, it's going in one direction because I've switched on F8. If you want to draw in any other direction, just try to switch on or off if F8. Let me give a dimension like this, and you can see it's going to be in one direction. Now, if you want to draw a line which is equal to this line, you can take a reference of the bottom line. How? Just scroll down gently, and you have to touch this bottom line like this. As soon as you go up, you can see there is a reference line. And if you click on that particular line, it will end. You can see that line ended over there. And if you want to connect, then again, try to drag like this. So it'll help us to find where our dimension is exactly. Now again, so if you want to join everything, press J, enter. If you want to copy this and copy in one direction, you can just copy like this. If you want to change the axis or the plane, you have to press F5. You can see it's automatically adding depth. And if this particular object is parallel to this object, the object which you are copying, you can see there is an yellow dotted line. It represents that they both are parallel. You can click anywhere you want, and then like you can like click something like this. You have your copied element which is parallel to our actual element. Then if you want to connect, just select TL again. Try to connect all the edges like this. And we have to erase the objects which are not visible in our drawing like this. So this will not be visible, And if you are looking from this angle, what is not visible? Can anyone tell? Will this line be visible or not? This
No.
line will be visible. This line will not be visible. And these three lines, will they be visible?
No.
Okay. If it is a shallow box again, this line will not be visible. But like a cardboard, just imagine as a piece of cardboard. Then will these three be visible?
Yes.
Yes, because if it is not a solid object, we have to remember what is the type of object you are drawing. If it is not a solid object, then these three lines will be visible. Okay. One more thing to remember over here is, I'll just try to quickly delete this thing first. One more thing to remember over here is, if you are drawing circles, lines, you can take polyline. But if you are drawing circle over it, like for example, there is a protrusion over here and something is coming out of it. Extrusion kind of thing, a circle and extrusion. Can you take a normal circle and draw? It is not, it will not be accurate, because you can see, I am in like, sorry, you don't have to change the environment. I am in 3D view, but this circle is not with the respect of this particular plane. Okay, just try to remember that you cannot draw a circle in perspective view or isometric view. In order to draw a circle, you have to always select ellipse. You can select any ellipse, and then you have to give your axis kind of here, and then you can just give your length of your circle kind of thing. Let's say you're trying to draw 500, enter. You can now try to give the axis. Okay, just by pressing F5, like this. So by pressing F5 and giving your correct dimension, you can give axis. So normal circle, it is with normal circle. In perspective views, it is not possible. So what we are going to use to draw a circle in perspective view is, you can just go with axis and or center, whatever the tool is, and then you have to select the actual plane in which you have to draw. So this is where I want to draw my circle, and then you can look at the center point. Like this is your center point, and this is your center point in this direction also. And then you can give your distance there. Again, you have to press gradually the x and y axis. If you are drawing a circle and you are given your x-axis as 500, you can actually give your y-axis also 500. Here I did not count on x-axis. Let me try to draw once again. And I am trying to draw over here, and I am giving my x-axis as 500 and y-axis also 500. So, excuse me. Sorry. So let me draw my ellipse, and giving my axis like this, and with proper rotation, you can see how this thing is going to look. And after that, now we have drawn one circle. You can just copy this CP, enter. You can just copy in the direction which we want. I'll press F5. You can see, okay, this is what the direction you want your circle to be. And say protrusion is to this angle. Then let me just take a line and try to connect between the two perspectives, or two axis like this, so that it will form a kind of a cylinder. After that, what I have to do is, I have to press TR and delete these two things. So sorry, it should be there because we are having depth, and cut. This circle represents there is a cut in this direction, and this here it is going to merge in our whole kind of square kind of thing. So it represents that we are having a cube with a protrusion in the form of a cylinder, right? So that's how we are trying to draw something in 3D view. So one more thing in order to notice, we have drawn in the 3D environment. We can also give the dimensions also in 3D environment. For that, I just go to annotate, just go to dimension, just take align dimension, give you dimension like this, press enter. I'm just trying to give 2 dimensions like this. Now, does the dimension match our isometric view here? No. This is in straight direction. This is kind of angle direction. So let me give a tip or how to correct this dimension. Just go to time edit and you have to select oblique. Now you can select the dimension, enter, and give the angle in which you have to protrude your dimension. Right now it's corrected. I'll just try to explain here with one more dimension. If you want to change the dimension according to our isometric view, isometric projection, what I have to do is DIMED diamond. It's a shortcut, dimension edit. And you have to select oblique. After that, you have to select the dimension which you have to edit. So this is what I am trying to edit. Click on that particular dimension, give enter. Now you have to select with which angle it has to travel. Let's say I am trying to give this dimension in respect to this particular angle. Give the angle 2 clicks. So dimension will be adjusted. Now it's more presentable, right? So this dimension represents this length, this dimension represents this length. How do we do? Just go for dimension edit, which is dim. It's a shortcut. After doing everything, again you have to come back to your normal drafting space. You have to turn off your isometric drafting view. Now we are back to our normal view. You can draw whatever you want. Once you have done with your isometric projections, we can normally come back to our isometric normal drafting view, or we can draw whatever we want after that. So by going to isometric environment, we are trying to generate this view with ease. Instead of drawing everything with angle, you can actually mention angle, draw this line, then give angle, complete everything with angles also. But it is going to take a lot of time, and also you have to imagine a lot of things. So to avoid that, we can actually go to this isometric environment and draw our isometric drawings. Now let's just try to draw one isometric drawing that is there. So let's try to draw this. We have drawn something similar to this. First, let's draw this. This is easier one. Let's draw this one. What I can do is I can just simply, if you want to load an object in your environment, just simply drag and drop. That also you can do, and you have to give an insertion point from where you have to draw. And this is a reference, right? I don't have to give any scale because this is a reference. And I want this until the image should travel until this length. And press F8 and give an angle. If you try to give an angle, so that image will be in your environment. Either you can go to insert and give a big process if you want to attach or give a PDF image in this format, or you can just simply drag and drop like this. Now I want to recreate this. Okay, so if you want to create some shape like this, you have to imagine first thing. First thing is always try to follow what is a bigger object in these two. Like let's say these are separate, and what is a bigger object in these two? For a moment, I think this bottom half is larger than our top half. So first, let us try to go to 3D environment, isometric view. Let's go to isometric top. I'm not bothered about dimensions at the moment. Let's just try to draw something which is similar to this without dimensions. Let's say 2000 mm. This direction, and this direction, let me say we are having 4000 mm. Again, let me draw a line like this. And if you want to draw parallel to this, you can just drag like this. You can see there is a point. That dotted line implements, they are parallel. And then I have to copy this thing to top in order to make one more projection. I'll just simply J enter. If I'm not taking polyline, if you're taking polyline, you don't have to press J enter because they'll automatically be joined. After that, let me copy, enter to the next plane, which is the top plane. You have to toggle between your environments to get that perfect view. Let's say I'm giving distance of 500. Okay, we have tried to copy. We have copied. The next thing is let's try to join everything. I'll enter. Okay, we have got this particular part of it, and let us imagine this as half. This is we don't have dimensions. That is why what I'm going to imagine is this particular part is from half. Okay, that will make our job easy. I'll try to locate where that half is. Okay, here is our half. Let me join the other half also. And now I have to give this given height. And this height will be on four sides. Okay, are you following me? Or any confusions here? Okay, so this height I'm trying to give, say, again 2000 mm. So here you can give any direction, but now let's say I'm going to give in this direction only. This direction will be obviously the length of this direction. So what is the length of this particular dimension? 1000. Right? Now my job will be easy because I'll try to join these two things. So again, select all those things, J enter. Now what I have to do? So these two sides are similar, right? So I'll just CP enter. I'll try to copy to this. I'll just try to F5 so that until I'm satisfied, I can toggle. The last thing that is remaining is you have to connect these both the lines. Now let us discuss what are the things that has to be removed. The first thing is we'll start from this direction. Okay, press TR, enter. First, this has to be gone. Right? This is okay for us now. Now the top, this has to be gone because that is not going to be visible. And also these two lines. Right? So here we are matching with this perspective. Now what else should be gone? So if we are looking from this direction, this should be gone. This should be gone. This should be gone. Now you can see, is this exactly of this, right? Is this the replica of this drawing? Is it yes or no? Yes. How did we draw? We did go to isometric view. We have taken all the polylines and we have drawn. Let's try to dimension this. How to dimension this? Go to annotate, dimension, select align, give your first point, second point, like this. Spacebar. So whatever the dimension you think that is important, you have to give. Like this. Spacebar. Okay, this dimension is finished. Let's try to give this dimension. Like this. And this is similar. This is similar, and two more dimensions. This is this one. So you don't have to mention. You have to mention one more dimension, that is this particular dimension, and also this particular dimension. So if you are mentioning these 5 dimensions, you can actually reproduce this object. So let's correct. How do you correct? Demerge is a command. Just go for oblique and select this dimension. It has to be in this flow. Just try to enter oblique, enter, click, select the dimension, enter again, and you have to give this dimensions flow. Like this is the direction you want to flow this particular dimension. Now again press oblique, spacebar, oblique, select the dimension, and you have to press enter again. This is the dimension you want to flow your dimmer, and oblique, select the dimension you want to edit, enter. Then you have to give your, I'll just switch off effect so it will be easy for us to view. Press enter. I'll just try to give this view if it is convenient for us. And there are two more things left. Select the dimension, enter. You have to give the perspective view which you have to draw. And then one more final thing is left is this thing. Enter, oblique, select. Say you have to give this particular dimension. You can give. Now it's much more easier. So this is the depth of this particular view, or sorry, this is the height of this angle. This is the height of this side of the object. This is the height of this side of the object. So we have all the dimensions of this object. Once you are done with that, your drafting, you can go back to your 2D projection or 2D environment with a simple click here. Turn off. After it's done, after you're done with your reference image, you can delete the image or save the image somewhere else. You have your isometric projection like this. Clear?
Yes, sir.
Everyone clear? So that's it for isometric projections. I'll try to give 2 or 3 examples for isometric projections. Try to follow those and try to reproduce these isometric projections and practice them. Okay. I think with this, I just want to stop today's